Hi, folks. Well, thanks for coming. By the way, some of the code that I'm going to be showing you is rendered, so it's going to render small for the screen. So if there's something you can't see, please scoot up. A lot of it won't, but some of it will, so I apologize. So anyway, thanks for coming to my talk on what functional programming can learn from Smalltalk. Unfortunately, that's a really bad title, because it's not about Smalltalk at all. Well, actually, it kind of is. It's not really about Smalltalk. So Smalltalk is just kind of a way to get to like the larger point. So here's a non-exhaustive things, a list of things about, non-exhaustive list of what this talk is not about. It's not going to be about the golden age of object orientation, about how things were always better in the 80s. It's not going to be about that. It's not going to be about how Smalltalk syntax can fit on a postcard. It can fit on a postcard, and we can use that to our advantage because I can just show you most of like Smalltalk syntax as we go along, but it's not really about that. It's not about static versus dynamic, definitely not. And it's definitely not about functional programming versus object orientation. Smalltalk is just a vehicle to a larger message about how language and environment are inextricably tied. You can't separate them. Sorry. And we're going to be using the Pharo Smalltalk environment to show that. And there's about 6 main points. And the first one is the most important. Without the first one, nothing else happens. And the first one is that if, in the next half hour to 40 minutes, you see anything that you think is cool, that you would like for your community to adopt, the first thing you need to do is spark a desire for that thing. Not go off and like hack on it and build it. Because everything flows from culture. Without culture, none of this stuff happens. And without culture, you will not be able to get this stuff into your communities. So the number one thing is culture. And the 4 like sort of concrete things that the Smalltalk community has been doing over the past 4 or 5 years that really make an impact, I think, and what we should be adopting in our yeah. Okay.
Oh yeah, I think you're just too far from the mic.
Yeah. Can you hold it?
I got to type when I do
Yeah,
this.
I'm gonna bring Ms. Chan for you.
Okay. All right. Cool. Thanks. Okay. Sorry about that. So the first big thing is this idea of localized code metrics. This is an idea that you can build a picture, like a diagram, a pie chart, a bar graph of your code base using sort of the advanced static introspection capabilities of Smalltalk. The other thing, and I think this is a biggie, and I think if this is adopted, it could change the way software is written across the industry, is this idea of collapsing indirection. Abstraction introduces indirection today. That's what it does. I don't know why it should, but it does. And collapsing that indirection, having a computer do that for you is huge. The next big things are the fact that we can have localized code visualization and debugging tools. These are debugging and visualization tools at the level of the DSL, not at the level of the language. What we have today is we have, if your language even has a debugger, it is a language level debugger. If your language has visualization, it is language level visualization. I'm talking about it at the DSL level. As in, you write a library tomorrow, and then you write a custom visualizer for that library and a custom debugger for that library. I'm going to show you examples of all of this stuff. So basically, what this comes down to is that if you have local and library-specific user experience, everybody wins. The language designer wins because they're no longer the sole arbiter of user experience. Advanced users win because they can design as they see fit without being held back by how to make this approachable for beginners. Beginners also win because they have tools that more clearly express intent, what the library author intended. Not having to reverse engineer what the library author intended by going through language level tools. So basically, a lot of what I'm showing you today is meant to sort of either ease or completely break this tension between abstraction and approachability. Because currently they stand opposed, at least in functional programming. So let's see what we're talking about here. I'm going to try and do this somehow. Oh, one more thing. I must confess my bias. When I first started researching this talk, I thought I could be ecumenical about what functional programming is, and it turns out I can't, because every cool thing that I found that the Smalltalk community was doing that I was personally attracted to would probably be more relevant to typed functional programming, because that is my background. I do that on the job, and I do that off the job. So I can't speak for, say, like the Scheme or the Clojure community, but I believe I can make some suggestions for maybe the Scala or the Haskell community, because that is my background. And also, I'm not a Smalltalk expert. So if there are strong Smalltalkers in here, please correct me. And this is also meant to be a semi-interactive presentation. I have a lot to get through. But if there's something that you want to know that I'm doing as I'm doing it, please just yell it out. And if I don't answer you because time is getting limited, don't take that personally. Just talk to me later. So, excuse me for a second. Can people still hear me now? I guess not. Oh, excuse me.
Now you're a rock star.
I apologize for being tall.
Right. Have a second. It's comfortable for you again?
Yes, perfect.
Right.
Everybody hear me? Thank you. Okay, cool. So let's just get started. This is our first live demo. This is the Smalltalk image that you get when you just go to pharo.org and download Smalltalk. This is what you get, just a plain thing like this. And everything lives in this thing called the system browser. The system browser is where all the source code for Smalltalk lives. It contains the implementation of Smalltalk itself. So everything down to the Smalltalk parser is available from the system browser. It's all broken up into these packages, so I can search for packages, so I can search for, say, collections packages, and there's like normal collections in here, doubly linked lists, you can't really see that. Let's see if I can expand it. Doubly linked lists and things like that. But say I wanted to look at stack, right? So if you click stack, it brings up the stack class. If I click the stack class, over on the right, it brings up the methods that it supports. It's a pretty small class. It supports push, pop, and top. So pushing is pushing things onto the stack, popping is popping things off the stack, top means look at the top thing on the stack. If I click hierarchy, it brings up all of the things that it inherits from. Don't worry about PP to stack for now. So stack inherits from linked list, which inherits from a bunch of collection stuff. If I want to use this, I can pop into this thing called a playground. The playground is like a REPL, but awesome. So a playground, so what does a REPL do? The P of the REPL prints something out. In a playground, the P is not a printer, but an inspector. So anytime you evaluate an expression, the result of that goes directly into the Smalltalk inspector. So if I evaluate this, so it's not only telling me that the value of that expression is 2, it popped me right into this inspector, and it's telling me, although you can't really see it up there, it says it is a small integer. So it is of class small integer. And I can get some meta information on that. So it's a small integer that supports all of these functions, and it inherits from integer, which inherits from number, and so on and so forth. If I hit Control B on the small integer, it takes me directly to that in the class browser. So there's a number of awesome things that you can do in the playground. So we can use that for our stack. So let's see. I'm going to introduce a local variable, and then I'm going to create a stack like that. And then onto the stack, I'm going to push nil. That's right. Smalltalk supports nil. And then I'm going to push a symbol. This is just like a Lisp symbol. This is the syntax for how you do this in Smalltalk. And then I'm going to push, push a string. Hello world. That strings in Smalltalks are single quoted. A double quote is a comment. I'm going to push a block. A block is a closure. It's just an anonymous function. And this block is going to take a stack, and it's going to take a value, and onto the stack, it's going to push a value. And let's take a look at this now. So if I run this, I get over on the right, you see the inspector. It's got the stack with the first thing being the last thing we pushed on, which is the closure, and the last thing being that nil thing that we pushed on first. Okay, and we can see other things about the stack. Like we go to meta, we see that stack inherits from linked list, and all of that stuff is sitting right here. So we can do things with this now. So I can grab the top thing on the stack, and I can parameterize that with myself and something 1. So what this is doing is invoking that closure, giving it the stack, and then giving it 1 so it pushes 1 onto itself. And if I run this, now the top item is 1. And because stack is also inherited from linked list, I can get to anything on the stack without having to like pop it off. So I can go s at the index, let's say I want that string, index 3. And at the first character of that string, by the way, Smalltalk is 1-based indexing, not 0-based indexing. So if you want to get, yeah, sorry.
Sorry.
Yeah, have fun with that FFI interrupt, yeah. So if you want the first character of that string, you have to go 1, and at 1 I'm going to put the character, and that $ is how you make a character, J. So if I run that, it goes from hello world to jello world. So everything in Smalltalk is mutable, and you have nils. So let's not learn that. That's not the part that I want you to learn. Like, that's not the part that FP needs to learn from Smalltalk. But that inspector thing is pretty cool. So we should probably take that. And the fact that we can get around really easily. So anytime you're at some source, you're writing some source, you can get to the thing that you're using within 1 or 2 hops. So you can either go through the inspector and go through that meta, or you can just double click that word and hit Control B, and it takes you right to the source of that. It just pops you right there. Another awesome thing that Pharo supports is this thing called a spotter. Spotter is exactly like Spotlight on OS X, except it indexes all of the classes, all of the messages, and all of the implementers right down to the menu items. So I can just search for stack and right there, and it pops me right to it. I can also use Spotter to search for messages. So I can search for put, and it's showing me all of the implementers of that. And I can just jump right to it. It also, if you really need a power tool, has this thing called a finder. And I can search for any phrase inside of the entire Smalltalk source. So now this is searching for self. Self is one of the most commonly occurring things inside of Smalltalk. And it indexed all of that in, what was that, 2.5 seconds or something like that? So this IDE is extremely responsive. And it's pretty mature. And it's useful for like real work. Oh, I gotta show you this thing. So what this does is when you have an IDE that's this responsive, it encourages you to play around and explore in a way that I think that a lot of functional code bases don't. So let's see, I was looking at Boolean the other day, and I think this has pretty much the best error message that I've ever seen. So if I click on the Boolean class and click new, if you try to create a new Boolean, you get this error message that says you may not create any more Booleans. This is a 2-valued logic. No 3-valued ternary logicians in Smalltalk, right? By the way, this also implies that I can just delete this right now. What? This also implies that I can just delete that error message and create my falsy object if I want to, because Smalltalk is like that. So anywho, so what we have is we have an IDE with refactoring support, very good refactoring support, and responsiveness that competes with the best commercial offerings that are out there. And I don't know what functional programming community you might identify with, but chances are that the Smalltalk community is smaller than that. They're a tiny community. They have not a whole lot of funding, not a whole lot of volunteers, and yet they've been able to build an IDE that competes with the best of them, IntelliJ. Eclipse. Yes, Eclipse is a nice IDE. Come on. Right. And I wanted to make the point that this all stems from culture. There is a deeply embedded culture of graphics and IDE in the Smalltalk community going back to the 80s. Like, a Smalltalker wouldn't think of like, why would I do this? And they're like, why would I do this in Vim? I want a real IDE. You know, why would I do this? So a community has got to want it. So spark the interest if you see anything that you like. Don't just start going out and hacking on it. For beginners, this encourages exploration and play. There's no reason to ask the basic questions because the image itself, the IDE, will guide you through the basics. You can engage with your community at a much higher level, much higher than most beginners are forced to do now in functional programming languages. For advanced users, it's the same. The exploration and the play doesn't stop. You still need it. You just use it for weirder things like weird control flow libraries and things like that. In fact, I'm convinced that a lot of the difference between an advanced user of functional programming and a beginning user of functional programming is that the advanced user has figured out how to explore and play in an environment that's actually pretty hostile to that. So as an aside, if you're teaching a functional programming language, I think one of the most valuable things you can teach a beginner is not just the syntax and the semantics and all of that, it's your tricks for how you get around a medium-sized code base and understand where things come from. So the next big thing I want to hit on is this idea of local code metrics. I don't even think this is a good phrase for it. It amounts to code-based visualization, but you have to build it on your own. So code-based visualization is something like, how many instance methods does this class have? You know, something like that, and put it on a chart for me. But if you took a turnkey solution off the shelf that somebody else provided for you and hit a button and got a graph, that's not what I mean. You have to build it for yourself. And you have to have tools to build it for yourself. And I think this has deep consequences for things like library adoption. Like, when do you take on a dependency? What does your personal code base look like? I think it has deep consequences for maintenance. When do you schedule that refactor? How spaghetti-like is your code base, really? Like, can you visualize that? Do you have hard numbers? And it gives people a sense of ownership. So let's see what I'm talking about here. Oops, I didn't mean to get there already. So, Smalltalk Pharo has a visualization library called OSAL. I know I'm saying that wrong, but I hope I said it okay. It's just like D3. It's no different. You're just plotting data, right? So here is a little sort of histogram plotter. It just takes this array. By the way, that's how you do arrays in Smalltalk. You have to put dots in between things. So you go 1, 2, 2, 2, 3, 3, 4, 4, and it's just plotting those out in this little graph. So this could be anything. This could be climate data. This could be like traffic patterns. It could be anything. But the really cool thing is that the Smalltalk community has used this visualization tool to introspect on their own code base. So for example, what I want to do now is I want a bar chart of all of the things, of all of the subclasses that inherit from like linked list. And I want to chart the number of lines of code per method on this bar chart. So let's see. So linked list, all subclasses, and let's see. For each one, I flat map over it, and I get all of the methods. Like so. And then I want that as a set because I want unique ones. And then along the y-axis, I can have a method and the number of lines of code for that method. And that's what that looks like. Same thing, same code, same visualization framework. So what we're seeing is, what we kind of expect to see this. Most of them are clustered around like 10 lines, which is good, which is fine. There's one guy at like 90. Okay, so that's good to know. So now, if you want to say pitch a refactoring week to your boss, or you yourself want to spend a week doing nothing but refactoring, not really adding any features to the code base, you have hard numbers with which to make that decision. So like for instance, and you could run this chart on a bi-weekly basis on your code base. And if the bottom cluster starts creeping up, maybe it starts creeping up to 20, 25, something like that, maybe there's a certain point at which you go, okay, now we know we have to start refactoring this. And that's really powerful to have, because you don't just have a feeling that your code base is turning into this spaghetti mess, you actually have hard numbers that it is, which is good. And not only that, metrics like this can make up for implementation deficiencies. So for example, functional programming languages usually have pretty good garbage collectors. That's because pure functional programming generates tons of garbage. So the garbage collector has to be good. The Pharo garbage collector Pharo is not known for its garbage collector. Let me put it that way. Okay, it's not great. But look at what we can do. Instead of leaning on the garbage collector to pick up our garbage as soon as possible, what about if we go out there and see, hey, what are all the instances of all the classes currently sitting in my image right now? Maybe there's one that's pegged at like, maybe there's a billion instances of one thing that you need to optimize away, or you need to bring down and just reduce the load on the garbage collector. How would you do that? So I can do that right here. So I can create a dictionary, right? And into that dictionary, I pull in all of the objects inside of my image right now. So all objects, like so. And for the sake of time, I'm only going to take the first 300,000. And by the way, this is pretty small. A typical Smalltalk image will have somewhere in the region of 2.5 to 3 million objects at any given time floating around, but that will take forever. So I'll just take the first 300,000. And with each one, I apologize for the formatting here, but it's the best I could do given the size of the screen. So I have an object, and for each object, I want to store the class that it belongs to. Like so. And in the dictionary, at that class name, if it's already present, I take a number, which is what's already there, and at the class name, I put a number +1. If it's absent, I just put the number 1. So what this is doing is iterating over the first 300,000 objects that it finds and tallying them up by class. So in this case, the points are just going to be the keys of the dictionary, and the method, and along the y-axis, you have a class name, and then you get the number of that class off of the dictionary. All right, fingers crossed. This could take a couple of seconds. Let's see if this works. Yay, it worked. Cool. So what this is telling you is that most things don't have that many things, like don't have that many instances. But this one guy, byte symbol, has 60,000 of them. And there's this thing called an identity set that has 40,000, and this thing called an association that has 20,000. This will take a while to run on your entire image. But once you have these metrics, and by the way, it's possible to limit these metrics to like things of only a certain class and things like that. You have a much better idea of what you can work on to reduce the load on the garbage collector. So even though Pharo doesn't have an amazing garbage collector, I think it's just mark and sweep or something like that, you can still write good software and still deliver responsive software because you have things like this. By the way, any questions so far? Okay, cool. So for the beginner, and by the beginner, I don't just mean a beginner programmer, I mean somebody new to your code base. This gives you a holistic understanding of your project. I've noticed that once a project gets over like 10K lines of code or so, especially in a team, there's usually one person that understands all of it. And everybody else works on little bits of it and doesn't really understand where they fit into the whole. Having diagrams like this is key for doing stuff like that. And if you're a beginner programmer, I can't think of a better way to build intuition that code is data. You're literally plotting code on a bar chart, right? And for advanced folks, you can have custom linters, custom diagrams for your library at a library-specific level. This is monitoring for your code base. This is DevOps on your code base with all of the benefits that brings. And this is for stakeholders as well. So the Smalltalk community has said, okay, fine. This should not, being able to visualize your code base should not be a thing that's restricted to only people who can code. So they built this thing called Data Studio. And I apologize for people who can't read that in the back. Please scoot forward if you can. So Data Studio is a way without writing a line of code, to build the kinds of visualizations that I just showed you. So I can take a view on all the collection subclasses, and then it builds them out. And then I can group them as a tree such that there's edges between subclasses. And okay, let me group that as a tree now. And I know you can't see that, but what this is doing is each collections class is a node of the tree, and you can see that if you hover over it. And as you go down into the roots, it's subtrees of that. And I can go ahead and normalize the shape of each node by other things. So I'm going to normalize the height of that tree, the height of each node by, let's say, the number of methods inside of that thing. So this might take a second to do. So what this is doing is it's saying, okay, the taller the oval, the larger the number of methods inside. So for instance, this is saying that, let's see, string has a large number of methods, right? So now you don't have to build these charts out for people who want to know things about your code base. They can do it for themselves without writing a line of code. And this is critical because beginners now don't have to write code. They don't have to like learn an API. They have to learn some stuff, but they don't have to learn an entire API to get a feel for what's going on. And there's tons of non-developers out there who are in charge of code bases, like scientists, administrative and support staff, and non-technical PMs and their managers and stuff like that. And if you're an advanced developer, you don't have to write any code. So that you're producing zero code, and that's a good day. So the third thing that I wanted to show you is this idea of collapsing indirection. I think this is a biggie. So before we start, just want to pull up the demo. So I created a deeply nested hierarchy of classes. So I have this class 4a with the method a on it that delegates to b, which is in 3a, which that inherits from that, which delegates to c, and so on up until d, which is the end of the line. So a calls b, calls c, calls d. So I can, of course, run this in the playground. And you can't really see that, but it says end of the line because it chased its way all the way back up to the parent class. It did that in a nanosecond. If I had to chase down that indirection myself, it would take me minutes. It would take me orders of magnitude longer to do what a computer can already do in like a nanosecond. But that's what we do every day. We chase down indirection all of the time. We do the computer's job for it. So the Smalltalk community has this thing called G-Toolkit. G-Toolkit, and this is the thing that I'm really going to have to ask people to, if you want to see what's going on, please come forward, is a rendering of source code such that all indirection is spliced in place. So this is that same A method that we just saw in the class browser, but next to B is this little arrow, and if I click it, it just splices B into place. And C gets spliced into place. And D gets spliced into place. So this collapsed all of that indirection for you so that you could read it without having to chase all this stuff down for yourself and waste your time. I think this is huge. I think that basically every programming language should adopt this, not just functional programming. Having to jump from like method to method to method to figure out what is going on takes up a huge portion of my time, and perhaps yours too. I don't know, maybe you guys all have insane short-term memories, I don't know, but like this is what I do for a living, right? And it also gives you a graph of the way things are connected, right? So if you click on the graph, there's A, there's B, there's C, and there's D, right? So this might seem like a small thing, but in my opinion, this is a game changer if you could adopt this. It has the potential to cut costs of software industry-wide without cutting quality. And I think that of all the examples that I've showed you, and will show you, I have one more coming up, this is the one that's easiest to retrofit into your community. Render source code and splice it in place. I spend 70% of my time chasing indirection. The other 25% is me trying to figure out what I was doing before I was chasing the indirection. And the last 5% is adding more indirection for the next guy. This is what I do for a living. Like, let's stop playing computer. We have better things that we can do with our minds than traverse an object graph, which this thing does like 1 billion times faster and better. For beginners, this makes it orders of magnitude easier to understand abstractions. Names matter, but they matter less. Okay, so let's say that you're in a Haskell code base and you see the name Kata. Kata means absolutely nothing to you, right? You look up the documentation. It is opaque. It points to a paper. The type signature is opaque, right? But what if you could just click through and splice it and splice in the source until it gets to a concrete implementation? How much easier would it be to understand something like fmap or even monads doing that, just clicking through, right? For advanced users, if you can count on beginners having this, you don't have to hold back. You can create the designs that you want to create without thinking about, oh my God, should I use the word row here or pi here, and like, will people be freaked out? They won't, because they can just click through. One of the biggest contributors of this tension between abstraction and approachability is having to chase down all this stuff yourself. When I first started learning Haskell, I had to do this myself by hand. So like, I didn't understand something like how fold left created a tree of like, sort of, I think a right-leaning tree. I forget which one, but I had to write it out and see it as it like expanded out. And how fold left and fold right relate to things like pairs. Couldn't see that because I didn't have the visualization tools for it. I had to do it myself. And language designers can now, they can design their languages without this fear that like people are going to be freaked out or consider it like beyond them or something like that just because they use a word or two that's unfamiliar. I think. I hope. So the last thing that I wanted to talk about is this idea of like local visualization and debuggers. I think I would accurately call it a domain-specific debugger and visualization. So here's what I have. The Smalltalk community has this thing called Petit Parser. Petit Parser is a parser combinator library. That's all it is. It's just like Parsec. It's just like any parser combinator library that you've used in your functional programming languages, except for this. For each thing, there is a specialized viewer and a browser for it, and I get this map that it derives from the definition of the parser itself. Now, this parser isn't in some string that's being like, marshaled into this map. These are just plain old Smalltalk classes and methods. So for instance, I know a lot of you maybe can't see this, but let's see if I can make this easier. This is a JSON parser. And I can click on any one of these subparsers and be taken to that parser, to that subparser, and I can see its source. And so I can also run a sample. So I can go hello world, and I know this is not valid JSON, but it is a valid pair. So I'm running a sample on a subparser of that JSON parser. And if I hit play, it shows me what it marshals to, but it also gives me a tally of all the nodes that it hit while it was going down. And it gives me this domain-specific debugger, execution trace, that I can just kind of click down it and see what's going on. By the way, and notice that on the sample side, you can't, oh my God, you really can't see that. That's crazy. So basically, as I'm hitting each thing, it's highlighting the thing that it's, can you see that at least? Yeah, it's highlighting the thing that is the relevant part of that input at that moment. So for instance, if I start at the top and I go hello world, that's valid JSON, and I get the thing that it marshals out to, but I also get this execution trace. But notice what else it's doing. It's showing me the paths that it didn't take. So once it gets down to this choice node, it's saying it wasn't a string, it wasn't a number, it was an object. This is already better than a debugger at this point, because the debugger just shows you what paths it did take. It did not show you what paths that it couldn't take, or it didn't. And this updates on the fly too. So I'm going to add some stuff to this parser. And I'm going to add the thing that everybody who's used JSON for the past 10 years has been screaming about. If you know it, yell it out.
Comments.
No, it is arbitrary code evaluation inside backticks. Yes, that's what I'm going to add. So here we go. So basically what I want is, so at any point I want to insert backticks, and I want to insert arbitrary code and have it evaluated as the JSON is being parsed. That would be awesome, wouldn't it? So here you go, a backtick, and inside of that I have a backtick mark as a parser, and then I'm going to have a petit parser to, let's see, predicate object node. I have to memorize this. With none of backticks. So what this is saying is, and like a lot of those star. So what this is saying is that like parse anything that's not a backtick once you're inside of that backtick context. And so I have, oops, I didn't mean to do that. Let's see, hope this works. And accept that, add that to there. And to value, add a backtick and automatically define that as an instance variable. And when I go back to my browser, I should see the backtick right there. And if I go to my map, there it is. And if I click on it, it should show me the source. And so now I can do things like hello 3, 2, 1 launch missiles. And it should just do it. And I can get a custom execution trace on that too. So that's what I mean by a domain-specific debugger and visualization. And I think we should have these. For beginners, this is a boon. Anybody coming into your library can get a quick overview of what's going on and where to go to get to different things. For library authors, a visualization that guides the user and a custom debugger that helps them out of a jam means that you have a lot more freedom to design. And there's no restrictions on abstractions. One thing that I could think of that would automatically benefit from this is any given stream library in a functional programming language. They're all extremely powerful and extremely good at what they do and extremely unapproachable at the same time. And it's easy to get yourself in a situation where you go into like infinite loops and things like that. For language designers, this means that there's less pressure as before on UX. So you don't have this pressure of like, I need to generate this really pretty error message for everybody. Because on the scale of like, there's you that knows the most about your application, and there's the language designer that knows the absolute least about your application. And when you complain to the language designer that error messages are not good enough, you are yelling at the person who can help you the least. But you are also yelling at the only person who can help you right now because of the way things are set up. We need to push user experience closer to the user. Like like the library that the user depends on knows a little bit less than the user, but way more than the language designer. And the library that thing depends on, and so on and so forth. They need to be in charge of providing meaningful feedback to the user. So in conclusion, IDEs are, I think, a matter of culture. It's not funding, it's not the size of the team. And they encourage exploration and play, and I think we should have them. At least IDEs like this. Forget what all the bad experiences you've had with IDEs in the past. I think localized tooling can make everybody happy. Beginners can help themselves. Advanced users don't have to hold back on design, and language designers don't have to fear that they're not doing enough for either of those two parties, because a lot of the responsibility is pushed off into the library authors. I think this is a good thing. Thank you.